What's up, everyone? This is LeetCode 621 Task Scheduler. So we're given an array of CPU tasks, each labeled with letters from A to Z and a number n. Each CPU interval can be idle or allow the completion of one task. Task can be completed in any order, but there's a constraint. There has to be a gap of at least n intervals between two tasks with the same label. We have to return the minimum number of CPU intervals required to complete all tasks. Okay, so basically, right, we're given these tasks and we're given an integer n as inputs, right? Really what it's saying is, so example one, right? We haven't, let's say we use an A, right? We have to wait two intervals, so 1, 2, before we can use an A. Let me do a space, before we can use an A again. So, boom, now we can use an A again, right? We have to wait 2 times, boom, boom, to use an A again. Likewise, right, if we use a B, we have to wait 2 intervals before we can use a B again, right? Really the trick to this problem is you just want to use the tasks that are most frequent, right? Because you want to minimize the number of CPU intervals to complete all the tasks. So it stands to reason you want to use the most frequent task first, because you want to use those up as fast as possible, because they're most frequent, right? So there's 2 solutions to this problem. There is a solution which uses a max heap and another solution which is a greedy approach. I'll show both, just for the sake of, covering our bases. The greedy approach is most efficient, but I'll show the max heap approach first, okay? So yeah, you can look at the examples if you want. I'm not going to go through all this because I don't want to make this video too long. So I'm just going to get into the max heap approach, okay? Of how we're going to basically, right, find out how we're going to do these tasks. Okay, and by the way, like if you obviously, like I said, look at the examples, but really the examples explain, right? Like, example 1, A and B have the same frequency. There's 3 of each, right? So we could do A, B, idle, A, B, idle, because the interval is 2, right? So you can't actually use an A here. You have to actually just idle. So an idle, of course, just means like you're not doing anything, right? You just have to wait. So we do A, B, idle. Then we can use an A again because the interval between these A's is 2, right? Right, we have the B and then the idle. So we do A, B, idle, right? A, B, idle, and then we can do A, B, right? We don't have to idle again. We don't have to idle again because we used all 3 A's and all 3 B's. So, how much time did these CPU intervals take, right? Or how many CPU intervals were required to complete this task, right? We had the A, so 1, 2, 3, 4, 5, 6, 7, 8, right? So our output is 8. Example B, right? You can just do these back to back, A, B, C, D, A, B, because the interval is 1, right? The gap is only 1, because n is equal to 1. Yeah. And then the gap has to be 3 for example 3, right? So when we use B, we have to wait 2 intervals, because again, n is equal to 3. So we have A, and then we have B, idle, idle, and then we can use A again, right? And then B, idle, idle. Then we can use A, B. Okay, so anyways, there's 2 solutions to this problem. There's a greedy approach. There's a max heap approach. I'll show the max heap approach first, okay? So really, the max heap approach, really, the idea is we're going to take these frequencies, right, of these letters, right? There's 3 A's. There's 2 B's. There's 1 C and 1 D, okay? And we're going to add those into a max heap, okay? Now, the max heap will just have the frequencies. I just added the letters here just for the sake of you understanding what these numbers are referring to. But the max heap will just have the frequencies, okay? So the idea behind the approach with the max heap is we have to wait after we use a certain task, right? We have to wait whatever n we have to wait n intervals, right? So the idea is we're gonna start with the most frequent letters, right? So first of all, we're going to handle this 3, right? So what we're going to do is we're going to have a heap, and then we're going to have a queue. And the idea is we're going to use up the most frequent letter first, right? So we're going to basically take this here, right? We're going to decrease it by 1, right? Because we're going to use one of the A's, right? So we want to decrease it by 1. And when we use this A, right? When we use this A, we're basically going to add, we're going to add this into the queue, right? So we're going to do 2, right? And we're going to have a pair, right? We're going to, and the 2 because we're going to reuse this eventually again. But the idea really is this, okay? We're going to take this A and we're going to use it up, right? So we're going to have 2 A's left over. So we're going to put 2 into the queue, right? For this position, like I said, it's a pair. And then in this position, it's going to be the time, right? So initially our time is just 1, right? Right, because we're starting at 1. So we're going to do 1 plus whatever n is, 3. So we're going to do 3. And that would give us what? 4. Okay? So what does this tell you? It tells you at time equals 4, we can actually use this A again, right? So we're going to we'll just do this. Boom, boom. Time equals 4. Right, we're at t equals 1. Right, now let's go to t equals 2. This is not in the queue, right? Because we removed it and we, or sorry, this is not in the heap because we removed it and put it in the queue. So now at t equals 2, what are we going to do? Well, we're going to use a b. So we're going to do 1. So we're going to subtract by 1, right? So it'd be 1. And the t is 2, so 2 plus 3 is 5. Right? This would not be in our heap anymore. So when we go t equals 3, right, none of these are 3. We're going to take this. And the idea is that we're basically going to use up these tasks, right? As we go. Now, let's say we get to a spot where t is equal to 4. Whoops. It's kind of hard to, whatever. Let me just cross this out. So when t equals 4, what we're going to basically do is we're going to basically take this, remove it from our queue, and put it back into the heap. Because now we've basically freed up our A's so we can use it again, right? So we're basically, so kind of the point of the queue is basically, it's like a placeholder for tasks that we can't currently use because we have to wait some set amount of time, right? Now, if we have a case where the queue has stuff in it, but the heap has nothing in it, we would just idle, right? That would be a case where we just idle. So we wouldn't really do anything. But then at some point, right, the time would come where we could actually take stuff from the queue and put it back into the heap, right? So so basically the point at which we don't have anything left over, basically at what point would we break out of the program? Well, if we have nothing in the heap, and really the point where we would have nothing in the heap is basically when the task frequency reaches 0, meaning we have 0 tasks left to do, right? So if there's nothing in the heap, and when it's 0, obviously it's not going to be in the heap anymore because we would remove it. But the point is when all these tasks basically reach 0, meaning when we use all the tasks up, we have nothing left over. So when the heap is empty and the queue is empty, it means that we used up all our tasks and we're not waiting on any task to free up. Meaning we know for sure now, because these are both empty, that we've handled every single task possible that we can handle. In which case, because the queue is empty and because the heap is empty, we're done. Okay? That's kind of that's kind of like conceptually how we're gonna handle it. Okay? So first of all, our heap, right? Let me go back. So for our heap, we need to basically count the frequency of these letters, right? But our input is really just a bunch of tasks, right? So we actually have to find a way to get these frequencies, right? So we're going to do this by using counter. You know, I don't like using built-in functions really because I don't know, maybe in interviews they wouldn't let you use that. So I guess we'll just do it manually. But we're just gonna have a hash map, and we're gonna map the letters to the frequencies. So our hash map will look like this basically, right? It'll look something like this. So we're gonna create a hash map called count, and we're going to do basically for t and task, right? If t is in count, we're just gonna say count t plus equal 1, else count t is set to 1. Okay, so we made our hash map, right? And now we have to sort. Or we actually don't have to sort because we're going to use a max heap. Okay, however, in Python we don't have a max heap, we only have a min heap, right? So what we're going to have to do, so we have some, like, let's say our values in our hash map are something like whatever 1 4 2, right? Well, the way, because Python only has a min heap, we're just going to set these all to negative. So that way when we pull the min heap will basically pull out the values that are biggest, right? Right. So this is kind of how you simulate like a max heap in Python using a min heap. Right? You just set all the values to a negative value, and it'll basically act as a max heap. Okay. So we're going to say max heap is count for count and count dot values. Okay. And we're gonna have to do some Pythonic stuff here to set up our max heap. And it's really a min heap, but we're essentially implementing a max heap, but like I said, Python only has a min heap, so we have to do this stuff here with the negative values. Okay. Initially time is just 0, and our queue we're just going to call it cooldown. Okay. And remember, it's a pair value, right? And the first value is our remaining count. The second value is basically at what time is this task available. Okay, and I will go here again just so you kind of get an idea visually. Okay, yeah, this problem is a little hard, so I'm trying to explain it as I go. Right, while our max heap has something, or our queue has something, it means we have to keep going. Okay, and at every point, basically, a timer has to get incremented by 1, right? Because we're at a new time. Okay, so for our first go around, obviously, time will just be equal to 1, right? Like I showed in our example. Okay, so basically, if there's something in the max heap, right, what do we need to do? We need to add 1 to whatever the count is, because remember, we set the counts equal to negative. So if we had something like, if our max heap was something like this, we convert everything to a negative, right? So basically this 4 here, we add 1 to it and it'd be 3, right? So when we use up one task, naturally, it'll start trending closer to 0 as we expect, right? So we're looking at our max heap right now. We're gonna decrement the count of our most frequent task, right? And remember, after we do that, we need to insert it into the queue, right? So we're gonna say count is equal to 1 plus heap queue heap pop max heap. Okay. Now we're not actually. I did say we're okay. When we use something here, we want to pop it into here, into the queue, right? Once we use our most frequent value, right? We want to pop it into the queue. But technically, when we use something from the heap, before we put it into the queue, we need to make sure that this is not actually 0, because let's say we're taking this 1 here. When we use this up, technically we have no more tasks left, so we don't have to add anything to the queue, right? So we need to basically do a check to make sure that after we use this task up, is there even more tasks left over of that same label, right? So we're going to say if count, right? Then we can add it into the queue, right? Because like if we only had one A, after we use that A, well, why would we add it to the queue, there's nothing to add, right? So we're gonna say cooldown.append, and then we're gonna say count. Remember, it's a pair value. The first pair is just the remaining count, and the second value in the pair is just the available time. At what time does it become available? The task become available again. Okay. Okay. After that, after we basically handle whatever we need to handle in our max heap, right? We're gonna check first of all if there is some task, because right now we're at whatever time is, right? Whatever value time is at. We need to basically look at our cooldown, our queue, and see, is there any task at this particular time that is off cooldown, and we can insert it back into the max heap. Okay, so we're gonna say if task cooldown is finished, basically put the task back into the heap. Okay. So we're gonna say if there's something in the queue, and the queue has the second pair value, right, is equals to time, meaning basically the cooldown for any particular task is done. So for example, when we use an A up, right, we add 2, or we put 2 here because we only have 2 remaining. We have 2 A's remaining. And it'll become available at time 4. So basically, if this is equals to time, so whenever time is equal to 4, right, that means this particular task is off cooldown, so we're gonna remove it from here and basically put it back here. Okay, that's all we're doing. So at this particular point, we're gonna say heap queue dot heap push max heap. And then we're going to say cooldown.pop left. And we're going to pop the 0th value. Right? The 0th value is just this, right? We're basically, because we only have 2 remaining now, right? Instead of 3. So we're taking this 2 and putting it into the heap. Okay? That's all we're doing. And then this is just our algorithm. So after we're done, we're just going to return whatever the time is. And the time will just be, time really is how long it takes to complete all our tasks, really, how many intervals, right? CPU intervals. I believe that is it. So I had some syntax there, but I don't believe. Okay. Yeah, that's our code. All right, so that's the, that is the max heap approach, okay? Now, we're going to have our more efficient solution now, right? So really, there's 2 solutions, right? So the first one, right? The first one is just the max heap approach, okay? And then the second one is more, it's a greedy approach, and it's a little bit like more formulaic, right? So the heap approach is really, I believe it's n log k, the time complexity, because we need to handle n operations really, but we need to also build the heap out, right? And the formulaic approach, which is the greedy approach, is O of n, okay? It's a little bit more efficient. It's a little bit more efficient, but it's also a little bit, it's like less intuitive, I guess, to understand. I will explain as best I can, okay? So let's clear this, and let's go back here, okay? Now we're going to go through the greedy approach, which is more efficient, okay? So the gist of it is, really, right? When we have an example like this, right, we can build out what our intervals should look like, right? Right? Because we can use so here we have 1, 2, 3, 4. We have 5 A's, right? Remember, we're going to use the most frequent elements first because we want to have the minimum number of CPU intervals, right? So obviously it stands to reason you want to use the most frequent tasks first. You want to handle the most frequent tasks first because, well, like I said, you don't want to make your intervals too long, right? Because if we use a B first and then a C, right? Well, it's going to be kind of weird at that point because we have an A and then we have to wait if we're using it. because we have to use all these tasks up, right? So why would you handle the less frequent ones first? Because then when you handle these, you just have to do a bunch of waiting, and you can't do anything. Whereas if you use the most frequent ones first, you have an A here, and you have to do a bunch of waiting. But hey, you can use the other tasks like a B or a C here, right? That's why you want to use the most frequent task first. Okay, so the gist here is you'll notice a few things. Okay, so when we use our most frequent tasks, right? We have basically these groups here, right? Right, like we have a group here, 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 and then we have an A, right? And so we can kind of formulaically build how we can basically account for the minimum number of CPU intervals, given that we can kind of structure it like this, okay? So the idea is this, okay? We're going to take the max frequency and subtract by 1, okay? The max frequency. So the max frequency really is how many groups do we have, right? So if A is 5 and we do 5 minus 1, we're going to have 4, which makes sense because we have 4 groups, right? We have a group here, we have a group here, we have a group here, and we have a group here. So there's 4 of these groups, right? So when we take the most frequent element, which is A, and we subtract 1, we get 4, right? Okay. Interesting observation. Now, when we do n plus 1, we get the size of each group, right? And that makes sense, right? Because n is how long we have to wait, right? So 2. We have to wait 2. We add 1 because we have to account for this A. So our size of our group is 3, okay? Okay, so there's 1, 2, 3. There's 4 groups, and each group is of size 3, okay? Interesting observation, okay? Now, max count is really the last group that isn't full. So it'd be this, right? But this could also be more than 1. Because, for example, if we had, let's say, 5 Bs, we would do 1, 2, these are bad Bs, sorry, 4. And we'd have a B here, right? So actually, max count would actually be 2 in cases where you basically have a tie in frequency for the most frequent characters or tasks, okay? And this will make sense, right? So this is basically our formula, given this, right? Because what we're really doing is we're counting how many groups are there, what is the size, and basically what is left over, okay? And that's basically how we're counting how many CPU intervals we have, because we're laying it out like this, right? Like I said, we're using the most frequent characters. This is the most efficient way to basically use your task is to use the most frequent characters first, right? So that's kind of the gist of this formula here, okay? Is because you're building out like the like visually we're building it out like this, right? But mathematically, this is how you would represent laying out your task like this, okay? So we basically we calculate the number of full groups, multiply by their size, and then we add the number of most frequent tasks in the final group. And again, our most frequent task could technically be like this here does not, like, we're not adding 1 always. It could be 2 or 3 if we have cases where our most frequent character is tied. So if we had 5 A's but also 5 B's, we would add 2 technically here, okay? So just keep that in mind. Okay. So, is this basically always going to be the case for a formula to count the minimum number of CPU intervals? The answer is no, okay? Because it could be just the length of the tasks that basically would give you the correct answer. And I have some examples to kind of illustrate that to you, right? Because really what we're asking, this is basically cases where we have idle time, right? And this is cases where we don't. That's really what we're asking, right? Are we forced to have idle time or not, right? Because we could use B, C, B, C, right? So we use this, right? But now we have idle time, right? So, so do we have to use idle time or not? That's really the big question in terms of how do we find out what the correct answer is? Because this formula won't always work. And again, I have examples to illustrate this. Okay, so example 1, right? We have A with n is equal to 2, right? In this case, we have idle time, right? So we're gonna have to use this really, right? And how does this work? Okay, our max frequency is what? Well, it's just A, right? So, and how many A's do we have? We have 3 A's. So we do 3 minus 1, right? And n, what is n? 2. 2 plus 1, that's 3. Okay, and our max count is what? Our most frequent character is A, and it shows up how many times? It shows up 3 times. Okay, but what is our max count of our most frequent occurrence? It's just 1, right? What does that mean? It means our most frequent okay, what task shows up most frequent? A, and okay, and how many times does it show up? It shows up 3 times, right? How many different tasks or labels show up 3 times? Just 1, right? Which would be A. For example, if we had 3 B's here, the answer would be 2, right? What's our most frequent task? Well, it could be A or B, and how much does they show up? They show up 3 times. This here is basically us asking, okay, what is the character that shows up the most frequent? It could be A or B, and so it'd be how much? How much does it show up? It shows up 3 times. Okay, how many labels basically show up 3 times? That's what we're asking, and it'd be, or yeah, how many labels show up 3 times? Right? It'd be 2, right? A and B, they both show up 3 times. That's basically what this is. So don't get it confused. Max frequency and max count are slightly different. So I hope that illustrates the point. Okay, so we're gonna calculate this, right, and we get 7. Okay. And that's what our answer should be, right? Because we have 1, 2, 3, 4, 5, 6, 7, right? So this minimum CPU interval time is 7. Okay. Now let's show you this case here. Let's see if I can. I'm gonna have to just zoom out a little so you can see this. There you go. Okay, this example here we have 3 A's, 3 B's, 1 C, 1 D, and 1 E, and then n is equal to 2. Okay. Well, let's calculate this formula first, okay? Just to show you the point. So the max frequency is what? 3, right? N is equal to n plus 1, n is 2, so 2 plus 1 is 3, right? Sorry, I don't know if I said plus 1 for this. It is minus 1 for the formula for the max frequency, sorry. So 3 minus 1 is 2, okay? Because we're subtracting 1 here, not adding 1. So I apologize. What is our most frequent occurrence, right? It is 3, right? Because A shows up 3 times, B shows up 3 times. So our most frequent occurrence is 3, right? So 3 minus 1 is 2, and n is 2, so 2 plus 1 is 3, right? So we have this. Now for max count, right? What is our most frequent occurrence? It's 3, and how many times does 3 show up? It shows up twice, right? Because we have A's and B's tied here. So max count is actually 2 in this case, right? So we do 2 times 3 plus 2, so 6 plus 2 is 8, okay? Now, how many tasks show up? 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, what is our minimum CPU interval time? The right answer is actually 9. I'll show you why, right? So if we set up our labels like this, right? Let's just use the A's, right? We have A, and then we have to have an interval time of 2. So boom, boom, A, boom, boom, and now another A. Okay, now let's use the B's up, right? We have how many B's? We have 3, so we can do, we had a B here, we had a B here, and again, we trying to make it fit, right? We can't add a B here. We actually have to add it here, okay? And so we use 1, 2, 3, 1, 2, 3. Okay, now we have C, D, and E. So we had C here, we had a D here, and then we add a E here, right? That's how we use up all the tasks. Okay, now let's count this out. 1, 2, 3, 4, 5, 6, 7, 8, 9. The correct answer is actually 9. It is not 8, right? So you'll see this formula actually does work, but it won't work in cases where we basically don't have idle time, right? The length of task is actually what gives you the right time in these circumstances. So Whether you use this formula or this formula is actually dependent on whether you have idle time. So, this is actually the bigger number in this particular example, right? So, in short, the best case, right? In the best case, we have no idle time, and in the worst case, we do have idle time, right? So, we want to minimize the idle time, right? So in this case, we actually don't really have idle time. So the correct answer is actually 9, not 8. Okay. So let me go up here, right? So this is a formula that's important, right? So keep this in mind. Maybe I'll come back here in a little bit. Okay. So we're given the task frequencies, but not the actual numbers. Meaning we're given the labels, really. Right, so we actually have to count up how often they show up. So we're going to basically do the hash map thing again. We're going to count the frequencies and then so count the frequencies and sort by the most frequent. Okay, and this is the more optimal solution. Again, we're just going to call it tmap. We're going to say for t and tasks. Right, we're going to say if t and tmap. We're going to say tmap of t plus equal 1. Else tmap is tmap of t is equal to 1. Okay, just setting up our hash map, counting our frequencies, right? So a is mapped to 3, b is mapped to 1, whatever the case for whatever example. Okay, so let's get our max frequency. Max frequency is what? It's basically which label shows up the most amount of times, number wise, right? So for example 1, it'd be 3. It could be a or b, it doesn't really matter. The point is the most frequent occurrence is 3. Okay, so we're going to say max frequency is basically the max out of all these values. So we're going to say tmap.values, and we're going to return the max. Okay. The max count is basically so we have max frequency, right, which is 3. So we're going to basically look at our hash map again and count how many times 3 shows up. So we're going to say max count is list. We're going to say tmap.values. And we're going to count the max frequency, okay? And again, remember the intuition is really whether we can fill the gaps or not, or whether we have to idle, right? So we're going to return the max for the length of the task, or our formula, which remember our formula is max frequency minus 1. And remember the purpose of the formula. It's really just how we would lay out these tasks using the most frequent elements first. But this, of course, would be cases where we actually do have idle time, right? So, and then times n plus 1, and then plus max count, okay? Times n plus 1, and then plus the max count. Okay. So yeah, basically we're choosing which is bigger, the length of the task or this formula. Okay, and remember, it really just comes down to whether we have idle time or not for any particular example, right? So the code's actually kind of simple, but I just had to spend some time making sure you understand the intuition of whether we would use this or this and why, right? So yeah, I know this video is kind of long, but this video is also long because I showed both solutions. So I kind of hope you understand. But yeah, this problem is actually really, really complicated in my opinion. Probably one of the more complicated ones we've done. At least in my opinion. But anyways, I hope this helped, and I'll see you in the next one. Peace out.